Alright, let's take a look at an example here where we're going to find all the zeros of the polynomial that is given to us. Alright, so in order to do this, the way that I like to start this out is by writing out all the factors of the constant out here, which I call p. So the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay. So for example, I could have positive 1 times a positive 6, or a negative 1 times a negative 6. Okay, so all the different factors that could get me to a 6 here, I call that p. Then I'm going to take my leading coefficient here, and I'm going to call that q. And I'm going to label all the factors of q in this case. So that's going to be plus or minus 1 and plus or minus 3. What I want to do here is I want to figure out one of the zeros of this polynomial to make this a little bit easier to find the rest of them. And the way you're going to do that is by taking your p-values and dividing them by your q-values here. So for example, different options I could get here would be 1, positive, negative over 1. So I could get positive 1. I could get negative 1. I could also take plus or minus 2 over 1. So I get positive 2, negative 2, and then so forth. Positive 3, negative 3, positive 6, negative 6. It also could equal plus or minus 1 over 3. So I could have plus or minus 1/3. I could have plus or minus 2/3. Plus or minus 3/3 would be the same thing as 1 and negative 1. And plus or minus 6 over 3 would be the same thing as plus or minus 2. So I already have those listed out here. So here's my possible values for p over q. Now, in order to be able to find one of the zeros here, I'm going to take these numbers and substitute them into my original function here and see when one of them will return a value for f of x of 0. This is basically called the remainder theorem. We're going to use these as our possible values of x. So these are possible values of x. Okay, possible values of x that would make this, or that would be a 0. So let's go ahead and try out 1 in this case. So I'll start with 1 here. Okay, so if we did f of 1, and I put that in, this would become 3 times 1 to the 4th minus 7 times 1 to the 3rd minus 9 times 1 squared plus 7 times 1 plus 6. So I'm going to go ahead and see what this equals. So we get 3 times 1 to the 4th is just 1. So that'll be 3 times 1. 7 times 1 to the 3rd is just 1. 1 squared is just 1. 7 times 1 is just 7 plus 6. 3 times 1 is 3 minus 7 minus 9 plus 7 plus 6. And in this case, 3 minus 7 gives me negative 4. Negative 4 minus 9 is going to be negative 13. Okay, so here these become negative 13. And this I could see becomes 7 plus 6 is a positive 13. And negative 13 plus 13 equals 0. So f of 1 does give me 0. According to the remainder theorem, that means that x equals 1 is a 0. So I know that x equals 1 is a 0. It comes from the factor. It also means that x minus 1 is a factor of the polynomial. So what I'm going to do then, in order to figure out some of the other zeros here, is I'm going to synthetically divide my original equation by my 0 that I just found. So synthetic division here, I'm going to go ahead and put my 1 in that box. I bring down the coefficients of my function. So the original function is, let me see if I can get it all in here. Yeah, there we go. The coefficients of the original function f of x are 3, -7, -9, +7, and a 6. So synthetic division, the way that this works here, is we just bring down the 3. So you bring down the 3, we multiply it with what's in the box. 3 times 1 is 3. -7 plus 3, -4. -4 times 1 gives me -4. -9 minus 4 is -13. -13 times 1 is -13. 7 minus 13 gives me -6. And then -6 gives me 0. And then I just go ahead and lower the degree on each one. So if it started with x to the 4th, I lower that by 1, it becomes x to the 3rd. X to the 3rd becomes x squared, and then x, and then we're left with 6 here. So now we have this new function. Let me get a different color here. Okay, so let's bring this function up here. So that's the 3x to the 3rd minus 4x squared minus 13x minus 6. Okay, so now let's try another possible value here. Why don't we try out -1 in this case? So this becomes 3 times -1 cubed minus 4 times -1 squared minus 13 times -1 minus 6. Again, we're trying to see if this equals 0, because then the remainder theorem tells us that that would be a 0 of the function. So here this will become 3 times -1 to the 3rd is -1, minus 4 times -1 squared is just 1. -13 times a -1 is a +13. Then we have minus 6 here. So it's become -3 minus 4 plus 13 minus 6. So this becomes -7 plus 13 minus 6. And -7 plus 13 minus 6 would be 0 in this case. So that tells me x equals -1 is also a root or a 0 to my function here. So I'm going to do the same thing like I did before. I'm going to do that synthetic division, taking those coefficients, and this time I'm going to use -1 in my box. And we'll have 3, -4, -13, and a -6. I bring down the 3. 3 times -1 is -3. This becomes -7. -7 times -1 is a +7. -6, and -6 times -1 is a +6. So we get 0. So this is going to leave me with this last function here, and then I'll bring down the x's. So it was x third, lower the degree by 1, so it becomes x squared and x. So finally here, we're left with this, and I'm going to bring this down actually over here. So we'll have 3x squared minus 7x minus 6. And I need to know when this equals 0 to get my other possible zeros here. And this I'm going to do by factoring. I'm going to use, I call this the AC method. Some of you might call it rainbow, eyeglasses. I've heard this called a bunch of different things. But it's basically the same thing as the AM method or trinomial factoring, except we multiply the A and the C term here to get -18. And now we're looking for two numbers that add to -7 multiplied to -18. So in this case, it'd be a -9 and a +2. So I'm going to rewrite this function. I bring this down. 3x squared. I split the -7x into -9x plus 2x. Bring down the -6 or the -6 equals 0. Then we go ahead and factor this by grouping. From the first part here, I pull out a 3x, and that leaves me with x minus 3. From this other two terms here, I factor out a 2. Leaves me with x minus 3. So then I factor out from those two terms, I factor out that x minus 3, and that leaves me at 3x plus 2. And then I just set each one of those equal to 0. and I'll solve this, and over here we'll get x is 3, and then right here I'll get that x is equal to negative 2/3. So my four factors here are that x equals 3. My four zeros here are x equals 3, x equals negative 2/3, x equals 1, and x equals negative 1 from before. So those are the zeros, which means my factors here, so these are the zeros. So this answers the question. Just so you know, though, the factors here then, factors, would have been x plus 1, x minus 1, x minus 3, and 3x plus 2. These are the factors, but the answer here we were looking for was the zeros. And there you have it.